So we're going to go over the study guide for geometry review for your quiz tomorrow. We're going to go over each question on the study guide and how we come up with the answer. I've taken a picture of the study guide so that it's on this page as well as this page, but I also will reiterate how to solve each one as we go through. So the first one, you're going to want to use a protractor. You can use a ruler also. So you would obviously measure using the ruler what each side represents, and what you will get is that each side is a different length. With that, we know that that's a scalene triangle, so that's where scalene comes from. And then if we measure each angle, you should get that at least one of the angles that you've measured is more than 90, which would make it an obtuse scalene triangle. And then if we look at the second problem, we are given a triangle that's labeled with two sides that are equal, so that would eliminate D as my possibility here. And I would just have an isosceles triangle, and then I would need to again measure each angle, and I should have gotten one angle to be over 90, which makes it an obtuse isosceles triangle. The third problem has us find a value of x and then the length of each side of the triangle. So if I draw the triangle, it says triangle DEF is an isosceles triangle. Angle E is the vertex angle. So I would draw it straight up and down and label the top angle as the E. So what this is saying is that these two sides are equal, which makes it isosceles. So then I'm going to label each side with what the value they gave us. So I have DE is 2x minus 7. I have EF as 4x minus 21. And I have DF as x minus 3. So if I'm solving for x here, I know that the top two sides are equal as they're labeled, and as it tells me it's an isosceles triangle, so I'm going to put them equal to each other and solve for x. So x would be 7, and then I would plug in each of the values for x into each side, and I should get two of them to be the same value and the third one to be different. So if I do the bottom one, I have 7 minus 3, so that means DF is 4. Then if I plug in 7 for DE, I would have 2 times 7 is 14, so 14 minus 7 gives me 7. And since that's the same side length as the one next to it, this would also be 7. So those would be our three side lengths. Now we're asked to find the measures of the sides of triangle DEF, and it gives us vertices. Now if we're trying to find the measures of the sides and we're given vertices, that means we need to find the sides by the distance formula. So if I have D as negative 7, 10, E as 15, 0, and F as negative 2, negative 1, I'm going to have to use the distance formula 3 times. So first I'll start with DE. So I subtract my x's, square them, subtract my y's, square them, and then I take the square, add them together and take the square root. So my y's, or my x's, it doesn't matter what you start with here. I have negative 7 minus 15 and 10 minus 0. So I get negative 22 squared plus 10 squared. Negative 22 squared would end up giving me, let's see, that would be 22 times 22. Let me do that the long way. I would get 484. So I have the square root of 484 plus 10 squared, which is 100. So I have the square root of 584. So that would be DE. Now I need to do the same thing with the next side, which would be EF. I'm just going in order. So EF, 15, 0, and negative 2, negative 1. I'm going to plug those into the distance formula. So the x's squared, or subtracted and squared, and the y's subtracted and squared, which is going to give me 17 squared plus 1 squared. Now 17 squared gives me 289, so I have the square root of 289 plus 1. So my answer would be the square root of 290. That's going to be EF. And then I need to do that one more time with FD. So if I go back, F is negative 2, negative 1, and D is negative 710. And I'm going to, again, plug it into the distance formula. So I get negative 5 squared plus 11 squared, or 25 plus 121, which gives me 146. And as you can see, all of these side lengths are 3 different values. So we would say that the triangle itself is going to be scalene, because it has 3 different values of sides. Now I'm going to come back to the diagram where you need to find all the different angles, and we'll go with number 11 next and come back to 5 through 10. So this number 11 gives us a diagram, a drawing of a triangle, or 2 triangles actually, labeled like this. So if you were to identify the congruent triangles in the figure, you are just identifying the 2 triangles. So that would be triangle LMO is congruent to triangle ONM. And that would be my answer. Next it asks us if triangle ABC is congruent to triangle DEF. Which angle corresponds with angle F? So what I need to look at is which one is in the same position on the other triangle. So that would be C. So angle C would correspond or be in the same position but on a different shape is what that means. So correspond with angle F. So angle C is my answer. And then I'm also going to, actually, I'll do the next one. No, I'm going to skip it. I'll do number 14 on the study guide, which gives us this figure. And we know that BC is congruent to CD, and BA is congruent to DE, and that C is the midpoint of AE, so that actually makes AC congruent to CE. So if you can see there, all the sides are congruent to all the other sides of the triangle. So if I'm determining which theorem or postulate to use to show that they're congruent, I would need to use side, side, side. And then what relationship do angles B and D have to each other? Well, if the two triangles are congruent, then you would also say that angle B is congruent to angle D. Now we have two figures that are congruent, and we have them labeled like this. So basically, if we know that they're congruent, we know that all corresponding parts are congruent. So that will be how we find each value, because we need to find x, y, z, and w. So let's start with w. 4w minus 7, BC, is the same position as RS, which also has a w in it, so 2w plus 13. So since they're in the same position, or they're corresponding with congruent figures, we know that we need to put them equal to each other. So we would put them equal to each other and solve for w. So I should get 2w, or I'm sorry, yeah, 2w minus 7 equals 13. So I'm going to keep solving for w. So I get 2w equals 20. So w would have to equal 10. Now we move on to, let's do the x's. If you see there's only one x, but if you see 2x plus 9 where that is, angle B corresponds with angle R. So we're going to do 2x plus 9 equals 49 and solve for x that way. So x would be 20. Now I'm running out of room here, so we'll do the next two on the next page. So z's, if we look there, we have 3z plus 10, and that is corresponding with z plus 16, so we're going to put those equal to each other. 3z plus 10 equals z plus 16, and solve for z. So z would be 3. And then the last letter, is y. And you can see that the two angles for y that are labeled with the y are also corresponding, so we can put them equal to each other. 2y minus 31 equals y plus 11. And we're going to solve for y. So y would be 42. And that would be all of our answers. And then the last one is going to relate to this diagram. And excuse my not so great artist skills here. And here we really don't have to go in order. We can kind of solve for each angle that's the easiest at the time. So you can really start wherever you'd like to start. I might start with angle 6 because I already know 105 and 41, so I know two out of the 3 angles. And I know that all angles need to add up to 180 if it's in a triangle. So that would help me do 6. So that would mean I have to add up 105 plus 41, which would be 146, and subtract that from 180. So I end up getting 34 for angle 6. Then I could do any of the next ones, really. I would maybe start with, you could do angle 5. That would work. And angle 5 and 105, they're supplementary, those two. So that would again mean I'd do subtracting 180 minus 105. And that's going to give me angle 5. So that's 75. Oh, I forgot to label. This is angle 4. 5 and 4 are vertical angles, so that's also going to be 75. And then we know that angle 5, 63, and angle 2 all have to add up to 180 since they're all sharing that straight line. So if we know that 5 is 75 and we have 63, we're just going to do 75 plus 63 plus x has to equal 180. So 75 plus 63 plus x equals 180. That's going to give me 138 plus x equals 180. So I'm solving for x, which gives me 42. And that represented angle 2. So angle 2 equals 42. So we almost have all of them. Now angle 3 is an exterior angle. That means we add up angle 2 and the 90-degree angle, which are the two remote interior angles. So we have 42 plus 90, and that's going to give us angle 3. So 42 plus 90. And that's going to give us 132. So that is angle 3. And then the last angle we have is angle 1. Angle 1, we have 2 out of the 3 angles for that triangle. So we can do 68 plus 75 plus x equals 180. And we get 143 plus x equals 180. So I get x equals 37. And that's going to be angle 1. So we've solved for all the angles. And notice we did not do them in order. So you can do them in any order that you'd like on the quiz, as long as they're using the proper types of angles that they are to be able to solve. So that concludes quiz review for tomorrow's quiz on lessons 4.1 through 4.4.